we know from experience a lot of people nowadays use turbidity sensors to measure solids. That's been used for years and years and years, mainly in New Zealand as well. We came in 2014, we started with a new product, Zerlik. And that's the presentation I'm going to share now with you guys. You can all see this?
Yep. Yeah, I've seen it twice before. I just reread it, so I don't know how other people have seen it. Whether you want to go through the whole thing or.
No, I'll skip a whole bunch of stuff because yeah, like in the beginning. So what you'll see, for instance, yeah, what's a wastewater treatment plant? I think we all know that. Or a water treatment plant, it doesn't matter which one it is. So for Zerlik, it doesn't matter. The most important thing is mainly how we use it, how it works. So basically, the unit uses an LED 880 nanometers wavelength. That basically means that we can see particles that are more bigger than 0.4 microns. That is the same as your the filter you use in your dry weight sample. That filter is basically a 0.4 micron filter. So we can basically tell people that the accuracy that we have is the same as your lab sample. That's how you do a calibration, single point with the lab sample. The good thing with the unit is basically that we measure the strength of the LED as well, and we measure the temperature. So we compensate for both. Big gap in the middle, that is basically so we don't have big chunks of whatever get stuck between, because of course if that happens you have an issue. This little black dot you see here with the 3 little holes, that is basically, I'll give you a close-up. This is basically the cleaning. So with high pressure up to 2 bar water or air, we spray it from those 3 little holes directly onto the lenses. So the cleaning is very effective with these units. This is for the geekies amongst us. How do we calculate the milligrams per liter? It's the Beer-Lambert law. We basically measure everything, so it's very easy for us to do a calibration and a calculation. You can do this by hand if you want. What's the main difference against turbidity? Well, first of all, we don't see color. So if you got water or you got tea, for instance, if we put our sensor in tea, it will come up with 0. You put a turbidity sensor in tea and it just goes nuts. That's the big difference with our sensors. So for dairy people, if you want to see color, if you want to see milk escaping or something, we can't see that. We only see solids. Yeah. The big thing is that we measure through absorption of the light, transmission, while turbidity measures scattering of light. That's the main difference. The problem with turbidity is, of course, that you measure in NTU units, and then you have to put a factor in there, the mathematical factor, to create milligrams per liter. While near-infrared technology, our output is immediately milligrams per liter. Like I said, easy calibration against a lab result. Clean water for us is 0. So you put it in a glass of water, it should be 0. Very easy. You normally don't have to do that with commissioning, but after a few years, we always tell people to once a while check it in clean water, because you could have fouling on the sensor, on the surface of the glass, and then of course your 0 is off. But it's very easy to see that. It's only affected by particle size for us, not the physical characteristics of the particles. Of course, if you do scattering, if you got a round particle or a square or a triangle, it changes it. And the main advantage against turbidity is our sensors do not drift. So basically, once we install them and you do a calibration, you don't really need to touch them anymore for calibration wise. People still trial it and test it. Now, of course, when we told everybody that, nobody believed us. So in 2015, the Hauraki District Council did a trial for the TSS sensors in an aeration basin in Levin. Basically, we had an Endresenhauser, the Huck, a quad beam, and our probe in one aeration basin here at the same depth, and in the middle was a sampler that basically took a lab sample every so often. Here you see, if we go a little bit closer, these little red dots are actually the lab samples. So for the Endresenhauser one, this is the calibration, the curve. So that's after calibration, and so we were allowed to go in, install the units, calibrate them, and then we had to get out, and the guys on site did everything else. So people of Lutra, I believe. So what they did, this is the output of the ENH. So they use a correction factor to bring it down, and you can see then it actually follows the lab samples pretty good. But of course, if the sludge should have changed in concentration, you would have an issue. The Huck unit is well, has some issues with some drifting, but if you bring it down with a correction factor, again, it's reasonably good. The quad beam has the same issue, lost data here, but I think that's more operator error. But the longer it's in the product, the worse the readings get. So this unit, this cleaning is not very effective. This actually is the raw data of the Surlic unit, so we have no corrective data, and the raw data was even more accurate than the corrective data of all the others. So, well, basically no comparison. This is the unit, and here you basically see how the cleaning works. Yeah, the first time I did it, I stood on the other side of the left and wet pants. But that's how the cleaning works. So it's the controller basically decides. You basically tell it how long to clean, when to clean, how long to freeze the signal. So it's all adjustable. These are the sensors we have from Surlic at the moment. This is the one that we use in aeration basins, DAFs, in stormwater drains to measure consent requirements. So that unit basically measures up to 20,000, so 2%. So very easy to use at 150, 200 milligrams a liter. We do have applications where we use that unit now. Tatua is using it now for, I think, about 4 years. And they now standardized on Surlic for the next upgrade that's coming. Inline units. The inline units go up to 5%, mainly used in return and waste activated sludge. This unit, basically the sensor looks the same as the sludge blanket unit. Same size, same thickness. That unit references all over the place. Panpeg is the biggest one. They've got about 6. Rangitiki District Council's got one. New Plymouth had one. They took it out because we had issues with lagoon sludge. And lagoon sludge is black. That unit just, as soon as black passes, you can't transmit the light anymore. So they had to go to microwave units. Microwave units can measure up to 30%. Different technology, it's microwave, but we can go up to 30%. If you want to go higher, we have other near-infrared units, but yeah, not much used at the moment.
What was that comment about black sludge? Sorry,
Yeah, so if you got lagoon sludge is very black. The problem that we had with the light is it won't penetrate the sludge to get to the other side. So can't basically measure it. So the unit basically freaked out every time we saw lagoon sludge. All the other times it was fine, but lagoon sludge is just black. It's like tar. It really, you could see a difference. As soon as it came in, you could see it straight away.
Okay, I would have thought that units that are working on scattering, I'd imagine, would have a problem. But
yeah, same.
I mean, why would a unit that's working absorption have a problem with that?
Yeah, like I said, because it was the concentration of it was so high that it just wouldn't go through. So that's when we use the microwave. The good thing is that we can actually, we got a portable unit that we can actually test it before we actually commit to put something in. So it's very easy for us to test it. But that was the only time we had an issue. All the others was very easy. Pardon?
A question for you. On your Surlic, can you have different path lengths? Or is that distance between the transmitter and the receiver, is that always fixed? Can you have a small, no, so that's fixed.
Fixed 880 nanometers, yes.
No, that's the wavelength, but the path length?
No,
So like
it's 20 millimeters.
Okay, so you can't have a 2 mil path length for really dirty stuff. Like the good example, no. Okay.
No, can't do it. It's unfortunately not with this unit. There's another. We use trios where we can do that, but that's another product. How we mount it? Well, we've got the rod and holder. That's what we use most of the time. So you just click it on the railing, and the unit just wiggles into the water. This is extendable up to 4 meters. It's like a big fishing rod. The inline unit, of course, we supply the nipple, the valve, so you just have to drill a hole, weld this onto it, and everything screws in. Here you see a close-up of the holder. The holder, basically this little lip, you can take that off, and then you can slide the unit out without touching anything else. So it's very easy to take the unit out if you want to have a look. If something gets stuck maybe, or a big rag get maybe stuck in the unit, of course, then you can have to take it out. This is the Waimakariri District Council. I think this is Wood End or Oxford, no, Wood End, where you basically see this is a TSS and a DO next to each other. This is the inline unit as the outlet of a DEF from Penpack, where they use, they mounted this, I think, about 3-4 years ago. And now, like I said, now they standardized on it. The DO sensor, like I said, with the DO sensor, we have optical or Clark cell. We are not more accurate or better than anyone else. This is exactly the same technology. We use the same sensors. Where we are, where we know we are better is the cleaning. Like I said, from 3 points, those 3 points, we spray up to 2 bar water or air directly onto the lenses. So cleaning is very effective. The advantages, like you saw this morning, is you can unscrew the cap here and just pop out the sensor and plug in another sensor. Doesn't matter if you got optical or galvanic. Very easy to do. We normally, at the moment, we standard we supply a galvanic cell, but if people want an optical, absolutely not a problem. Here the mounting. So again, the rod holder, and we have a slide rail as well. But yeah, we have people who do it, hang it on a chain. Like I said, as long as it's in the water is fine. Yeah, it doesn't really matter how you do it. This is a nice way, but like I said, just make sure that you can take the unit out for whatever reason you want to do it. This is the controller, how it looks. So we have a BB1 and a BB2. The BB1 can take 1 sensor, the BB2 can take up to 4 sensors. What the unit basically does, it just takes the sensor. You can control the cleaning with the unit, the 40-20 milliamp output of the unit, you can set that. And for calibration wise, you basically use the controller as well. So mainly if we do the commissioning and we come on site, that is where we sit, and that's what I show you. The controller, we don't really touch the sensors anymore. Don't really have to. Here you see that's, I think, Oxford at the Waimakariri District Council. Here you see the controller with the valve. So we supply the valve normally as well. But like I said, if you want to do that yourself, it's like if it's just a valve to transport the water, basically. That's all it is. Or air. I think they use air. So yeah, why we tell people why choose Solic? Well, mainly we tell it's mainly for the local support. So the guy you just heard was Owen. He's from our office. He's from Homershams. Homershams is a sister company from Teltherm in the South Island. Martin is also online with us. Martin is basically my colleague in Auckland. I travel all over the country, so you will always be supported locally. So I live near Hamilton. I do South Taranaki, basically the rest of the North Island. Building cleaning, of course, low maintenance, and that's what we tell. Operators don't really need to touch these units anymore. This is what we would like to see in the wastewater treatment plants and water treatment plants. But yeah, this is a bit bigger. This is not us. Now your sludge blanket unit. The sludge blanket unit uses the same sensor. Yeah. You know it's, well, what people currently use is a sludge judge, ultrasonic sensor, or what we call an iometer. Basically, they just look. Well, that works most of the times. The problem is if you get a problem. This is what you want to see. So the sludge blanket system basically is what we call a yo-yo sensor. The sensor sits in here, goes down, measures whatever you need to measure, sludge, fluff, and goes back up. While it does that, it does spray water onto the sensor when it goes down, basically to wet the sensor. And when it goes up, it sprays the cable and the sensor clean as soon as it's in there. This is basically what you want to see. This is what you basically, yeah, that's not very good. And this is, well, that is very bad. The problem at the moment is that most people use the pumps and they run only on timer. So you don't really know if you're pumping out water or actually sludge. So the unit is not very cheap because we're looking at around $18,000 for the unit, complete system. But you can reduce your cost very rapidly, mainly energy and chemical costs. This is what the unit basically output. So you give it a value for the fluff level and you give it a value for blanket level. When the unit goes down, two outputs, one will be fluff output. It will tell you where it finds in here 1000 milligrams per liter. And when it hits 1%, it will tell you exactly what the height is as well. Output number 3 and 4 is basically depth versus concentration, or height versus concentration. You can choose that. So basically you see the profile. That's basically how it looks like. In your SCADA system, you can actually create this. New Plymouth did a very good job of showing this on the screen as well while the sensor goes down. This is basically what you want, but yeah, if you got this, an ultrasonic will have an issue with here because it will see this layer, not the actual layer. So there's a few things. A lot of things you can see that the unit will give you. So a lot of detailed information. Now here is basically where you save your energy. So if you can pump sludge into your digester and you can actually say instead of 2%, I do 3 or 4, you have a massive reduction in costs. They did some studies. One was in Sweden, where they basically had a payback time in 26 days. But 700,000 kilowatt hour a year, this is a big pump. So it will be a lot longer in our cases, but I think you get the picture. Huh? Polymer dosing. Again, polymer dosing, very expensive product. This unit will control your polymer dosing accurately. So even if you got a rain event, whatever happens, the unit will keep telling you exactly if you got a lot of fluff or not, or settlement. So it will basically control everything. And of course, you don't want to truck out water. You want to truck out the sludge. The thing is, of course, early warning of settling problems. That's where these units come into play. If you got a beautiful site where you got good settlement, then anything works. You can use a sludge jet, you can use an ultrasonic, everything works. It's when problems start to happen. That's when you want to see the units actually giving you the data constantly. That's what this unit is valuable, because when shit happens, this unit will keep giving you information. So basically, yeah, well, if you optimize in the beginning, the rest will follow. Yeah, it's like I said, if you do it good in the beginning, the rest will follow automatically. This is basically how the unit looks like. What we supply is the unit, the bracket, the controller, and basically the background. That's the inside of the unit. So it's a big drum where the unit goes through here. This unit requires a little bit of maintenance. Normally we tell people once a year, check that you not have spider webs or anything caught in here, because this is a roller. All the rest is basically just, yeah, again, don't touch it. Installations in New Zealand, we've got quite a few. We've got one in Rollaston. This is, I believe, this is either Rollaston or Tauranga. What you see here, this is just a PVC pipe. The reason why we put that on there is so when the sensor goes up and you got a high wind, it won't hit the railing here at the bottom or anything, or the scaffolding, whatever you've got here. So this is just a protection. That's all it does. So it's just a 90 mil PVC pipe. You just clamp onto it. The right side, this is from Yamamoto. They had an unfortunate event where a lightning hit the unit. Yeah, that didn't like that. This is a Invercargill Branksholm. I think this is a water treatment plant where we got a unit. They've got 2 units. This is one at the clarifier. On the right side, this is the new Plymouth one. Now it looks like, well, really bad, but this is when they just started up. You see at the scaffolding, they were still building a whole bunch of stuff. We just installed and commissioned the unit. You see here the water basically onto the muck. We basically just commissioned the unit, but yeah, the clarifier was, they were just filling it, so it was not really up to scratch. Now, what's the difference against ultrasonics? Well, first of all, we define it as a concentration, the sludge level, while ultrasonics looks basically at densities. We give you 2 levels, fluff and blanket, while ultrasonic gives you 1. Not very accurate, but gives you 1 level. We are not affected by sedimentation properties, while ultrasonic, if you have poor settling sludge, ultrasonic will get into trouble very quickly. We can show you also a profile. You can't have that with ultrasonic, of course. And then the most important thing is that the sludge blanket system will work no matter what type of settling properties you have. It will always work. Ultrasonic, of course, is disturbed by changes in sedimentation properties or density. So only works if you got a beautiful, nice settling. Of course, we can come to site and do a trial with a portable unit. The portable unit is basically identical, just no output, but this is a 250 point data logger. I can come to site, so I've got 1 unit with basically the 3 probes. Blanco is a sludge blanket sensor, Oxydew is the DO, and the solid sensor. It's like the 5% inline unit. I can just plug it in, throw it in there, and it tells you basically what the profile is. We normally use that. If you're interested, we use it to determine what the best position is to mount the unit. Also for your solids, that's what I basically use. If you want to measure solid somewhere, we just poke it in with this unit and we can tell straight away, yeah, we can measure it, yes or no. Just a portable. There are quite a few smaller councils. They bought the portable unit because they don't want to spend $18,000 on a sludge blanket or $10,000 on the inline unit or the submersible unit. They go with the multi-tracker, the portable unit. Now, what do we have else with the infrared technology? We do have inline units to measure POD, COD as well. We can also measure nitrates inline or in a pond or whatever. Yamamoto uses our nitrate sensor. These units, we can change the bandwidth, the wavelength and the distance. We can change that with these units. This is a company called Trios from Germany, where we have also full spectral analyzers. Basically, it's a competition against SCAN. The difference is it's just, well, a lot cheaper, but that's the same thing. They use the same sensors, basically. That was it, guys. Now, any questions? I'm just gonna go back to my screen. That's a little, we have, like I said, we have quite a lot of references. Few in New Zealand, now we have heaps of them in Australia. So Sydney water is now standardized on Surlic as well. I send you all that little paper